GetComponent is not bad. Using it without understanding is. Today I want to show you what GetComponent really costs. It's not just about performance, but also how your code ages over time. By the end of this video, you'll have a good knowledge on when to use GetComponent and most importantly, where. If you stay until the end, I will give you a bonus, huge tip that will really help you work alongside GetComponent. Welcome to 100 Tips in Unity. This is episode 12. So what is GetComponent? GetComponent is a generic method that lets you search for a component in a game object. That's it. It either returns a reference of that specific data type that we requested, or it returns null. And it just simply does a lookup. Okay, it's not magic. Now this line by itself is fine. It will work. And if this was expensive, then Unity wouldn't work. Now there is a little bit of thing that we can do immediately. Right now, a rigid body RB, and we say RB equals GetComponent rigid body at start. And this is what a lot of tutorials will show you. But there's a better way to do this. The way we can improve this is by shifting this code from start to awake. So void awake, and we cut this line and paste it here. Why is this better? Because awake is meant for get components within the same object. If you put it inside start, it's not a big difference. Okay, it is okay, it is acceptable. Start is mainly used if you're getting a component from another game object, because we need to make sure that that game object is awake first. So all of the components are loaded and stuff like that. So if you put other game object dot get component rigid body, then you put it inside start. If it is on the same game object, you put it inside awake. It is a simple coding practice. Okay, but this is where a lot of people might stop. But good programmers would do something like this. If RB equals null, debug.log, node rigid body attached to game object.name. We can even say log error, because this might be an explicit dependency. So this is one way to do it. You should always check for null if you're getting component inside awake. But there is a better way to do this. Again, 1,000 different ways. Okay. But let me explain. This is better than doing nothing. And the way you do it is by adding the RequireComponent type of rigid body. This forces Unity to add a rigid body whenever you add this class. Let me show you. If I create an empty game object and then drag this script, it automatically adds a rigid body component as well. So now GetComponent is sure to work. Now let's look at GetComponent in update. This line of code runs every frame. There is a hidden repetition and it is easy to forget. And then you can stack different get components as you age. This is a simple and easy performance trap because you don't need to get component every frame. And it's the actual problem is not this version of the code, but version number 10 of this code. Meaning the more things you add, animations, sound effects, all those things, you might add more get components over there without even knowing it. And that is the problem. So everything matters. If you were to do the same thing, it's better to cache it. We say rigid body RB, awake, and then RB equals get component rigid body. And then we also make sure that there's a require component type of rigid body. And here, instead of add force, we say RB.add force. This is not going to do that get component check every frame, but it will give you the desired result. Okay. Because this is physics, I recommend using fixed update, okay, rather than update. Because if you use it on fixed update, you're guaranteed good results. If you use it on update, you're risking instability. So for this next topic, I've created a weapon class which contains a shoot function. And in another script, I'm going to say weapon equals get component weapon. And if weapon not equals null, we shoot the weapon. Okay, this is a very simple example. You're doing it only once, but you are shooting it. Only when it's not null. You can also add a require component type of weapon if you want. But what is the problem with this approach? The problem is coupling. Right now, get component example, which is the name of this class, is tightly coupled to the class weapon. In fact, both of these should not get coupled. Both of these does not make sense together. This seems fine early because a weapon class really do exist. Your team might be small, so nobody's gonna know, and your scene is controlled. Okay, but the problem comes when you age this project. or when it becomes bigger and bigger, especially if you're working in a team. Someone might duplicate the object, or someone removes a weapon, or someone forgets to add it back. All those things could happen. There's also a possibility of null reference at runtime, which we are dealing with it here. But yeah, there is no such thing as editor warning unless we add the RequireComponent attribute. So you shouldn't forget to do that. And bugs will appear late in development, not now. So that is the problem with this approach. So it doesn't break code today, but it breaks trust in your code tomorrow. That's what will happen. And how do we get rid of this hard coding? By using two things, that is to use events and interfaces. So the weapon may implement an interface called IInteractable, which contains an interact function. And here IInteractable, let it implement, and we can press Control and period on VS Code or Alt and Enter on Visual Studio, and then implement the interface. And here we can call the shoot function. Okay. Now here, instead of getting a weapon, we firstly cache the IInteractable interactable equals getComponent IInteractable. If interactable not equals null, interactable dot interact. Now we don't need a RequireComponent of weapon, but we need to make sure that weapon is added. Okay, but this is not how usually games work. You actually need to create an array of interactables and get components IInteractable item in that array. That's how you do it. But yeah, interfaces will help you with decoupling. And also you can use events on top of this to trigger this interaction. And that's beyond the scope of this video. Let me know if you want a video on events in Unity. Okay, in this example, we have an onTrigger stay. And we are getting the rigid body, and then we are checking if it's null, we are printing the mass. What is the problem here? It's an onTrigger stay. If this was an onTrigger enter, it is only called once. GetComponent will only be called once, but because it's on onTrigger stay, there's a big chance of it happening multiple times. So you can cache this if you want, if this is something that's happening all the time. But if it is like a one-time thing that you want to implement, then why are you wasting memory, right? So you might want to use GetComponent on trigger stay, depending on how big the game is. But there's another problem to this. That is, this might get slow if it returns null. If the rigid body is found, then it's fast. But if it returns null, then the process gets a lot more slower. Even though we are checking for null reference down below, the lookup is still happening, meaning this line may take some time. So how do we solve this issue? We solve it by using something else called TryGetComponent. So we say if other dot TryGetComponent rigid body out rigid body, and then we do this. If it exists, print the mass to the console. Now you can see the code is a lot more cleaner, and we have a TryGetComponent function. A TryGetComponent function returns a boolean. Okay, it is used inside an if condition, and here we try to get the component of type rigid body in this game object called other, which is a collider, and we are outing it, meaning we're storing it inside a temporary variable called rigid body RB, which exists only inside this if condition. And now we can say debug.log rb.mass, and this will only work if we successfully find the component. That is it. Now we can also add an else, no rigid body component found on the other object. Cool. So this is significantly better if you are doing it repeated times, or if there is a chance that this rigid body could be null. So if you are getting the component from other game objects, it's better to use TryGetComponent instead. Okay. This is something that you do inside update or trigger stay. In start, you can use the normal get component and then check for null references later, because that's okay. It's happening only at the very beginning of the game. But if you're doing it repeated times, like in update or in on-trigger stay or in coroutines, it's better to use TryGetComponent. The final example, there is still a bonus coming up after this. We're looking at on-collision enter, getting a game object, getComponent, weapon, shoot. Okay, this is good because we're doing it only once, right? But can we make it better? Of course. Currently on collision with every object, we are trying to get the component of weapon. One way to solve this is to add an if condition, if collision.collider.compare tag, let's say weapon or something. So if we collide with the weapon, we are shooting the weapon. Something like this is infinitely better than putting it blindly inside on collision enter. right? We are filtering it only when the collided object is a weapon. But is there any other way that we can do this? Of course, the best optimization in this case is preventing unnecessary collisions, and that is to use the collision metrics. Let's say there are two layers called the player and the weapon. You can go to edit, project settings, you can go to physics, and then settings, open up the layer collision metrics. And here we can make it so that the weapon only interacts with the player and not even other weapon. Okay, but the player will interact with everything else. Okay, so the weapon doesn't interact with anything except for the player, but the player will interact with the weapon. And in this case, instead of putting it inside the player script, assume this is the player script, we put this inside the weapon script, and on collision enter we just call not even get component but just shoot. Because we are inside the weapon script now, we are completely avoiding get component, and we are using it inside the weapon script and not the player script, and the weapon only interacts with the player, so we know for sure that this is inside the player, so now we can successfully shoot. But in the other case, we need to filter for other things. It could be enemies, it could be obstacles, it could be weapons, anything really. And this is way much simpler because right now we are doing it on the weapon instead of the player, and we are completely avoiding get components. So this is better, infinitely better. Let's say we have a projectile. A projectile must deal damage when it hits anything. So on collision enter, it should deal damage. But it should deal damage to anything really. If it should deal damage to environment, it should deal damage to player, enemies, maybe barrels, anything really. And the way it should implement should be customized to each object. For example, a barrel might explode, but a player might just simply take a damage. So how do we deal with these kind of things? We need to get component, but what? So I just want to introduce to you a simple workflow that will really scale your game or make the code a lot better. That is to use abstract classes. I've created an abstract class called damageable, and an abstract class can contain abstract function. For example, in this case, we have a public abstract void take damage, which takes in a parameter int amount and a semicolon. This is an abstract function, which means the base class does not need to define this function, but the child class can. Okay, this is great because it forces child class implementation. You can also use virtual functions and not use an abstract class. That works fine as well. Or you can just use an interface as well. That also works technically. But I prefer this because it forces you to write specific code for each object, which is something that I like. And it's very simple. It's just one line of code. I like things clean. So public abstract void take damage int amount. Now let's say we were creating a barrel. So I'll create a new script. Now instead of mono behavior, we can inherit from damageable instead, because damageable is a mono behavior. So if you hover over it, it does not implement this thing. So you can quick fix, implement the abstract class, and now you can have a custom take damage function. So you say debug.log barrel took amount damage. Okay, it's simple as that. Now we can have another class enemy, also implement a damageable. We can quick fix, implement the abstract class. Now enemy can also have a custom function. So debug.log enemy took amount damage. In the case of barrel, it is barrel took. We can even say debug.log barrel explodes or something like that. So barrel can have its own custom implementation. Same goes with enemy. And here in the projectile, we can do this line of code, but it's better to try get component here. Okay, if collision dot game object dot try get component damageable out damageable dot take damage. Why are we using try get component instead of get component here? You can use get component here because it's only on enter. It's perfectly fine. Try get component just checks if it is damageable or not. Perhaps this also interacts with walls, which is not a damageable. Okay, because this is a projectile and it could interact with walls, which is not damageable, but it should collide. So walls have a chance for not to be a damageable. So in those cases, it will return null and it might lead to a slower performance issue. But if you're using TryGetComponent, it's a lot better. Okay. Plus you can use the collision metrics and filter out collisions that are unwanted. Okay, so that is how you do it. And the thing is, this keeps working as the project grows. Meaning, if you were to add another type of enemy, so for example, we can create a class called Food Soldier and inherit from enemy. Here we can still override that take damage and say Food Soldier took this much damage instead of enemy took this much damage. So right now we have a custom Food Soldier which also has its own take damage function where it's different, right? So it's insane. So if you have a Foot Soldier with a shield, you can do a different thing. You can do all sorts of cool stuff. And this grows well. Using class inheritance with GetComponent is insane. So you can see that GetComponent isn't the problem. The problem is code only works when the project is small. So if your code hides assumptions, it will hurt you later and not now. So you need to write code that survives refactors and also survives new teammates and your bosses, and it should also survive time, which is the most important bit. And that's how Unity projects actually scale.